So，大家好，我叫那哲斌。My English name is Nabudi Prasetya。我的税号314-354-09。Today I want to present my final exam, method of civil engineering about early dismantling of aluminum formwork systems in high-rise construction. And this research based on the research and development Vietnam. So in this modern construction era, speed is just as critical as structural integrity. The primary focus of this research is to evaluate the impact of removing aluminum formwork early, specifically on reinforced concrete beam slab systems. We are looking at how this affects punching shear, capacity, deflection, and crack width. The goal is to provide practical guidelines that balance rapid construction with absolute structural safety using finite element analysis and real-world examples. And then the aluminum formwork system components. So before we dive into the data, let's look at what makes this system unique. Aluminum formwork is composed of 4 main elements. The first one is the aluminum frame, lightweight but high strength, primary structural component made from lightweight, durable aluminum alloy with high load bearing capacity and corrosion resistance. And then the second one is formwork surface, direct concrete contact layer with special aluminum coating, creating smooth surfaces for easy removal and beautiful finishes. Third one is connection system, bolts, screws, and locks connecting panels into sturdy units with flexible size and shape adjustment capabilities. The last one is bracing and support, aluminum or steel bracing bars reinforcing formwork stability with base plates and supports maintaining ground stability. And then the advantages versus the disadvantages. Why use aluminum over traditional timber or steel? The advantages are clear. It is 100% recyclable, provides a beautiful concrete finish, and most importantly, it enables a 48 to 72 hour reuse cycle. This leads to a 20% to 30% reduction in total construction time. However, we must acknowledge the challenges. There is a high initial investment and a reliance on foreign suppliers because the component positions are fixed. The system has less flexibility for design changes once on site. Therefore, precision in the planning phase is mandatory. Critical safety verification criteria. To ensure safety during early removal, we adhere to TCVN 5574 2018 standards. We focused on 4 critical criteria. First one is moment and shear capacity, evaluating the slab as a continuous beam. Then the second one is punching shear. This is the most critical safety factor, evaluated through a 45-degree punching cone. Then the third, crack width, which we must keep under 0.4 millimeter to ensure durability. Then the last one is deflection limits, maintaining a ratio of 1/250 of the span length. And then this is the case study of Asiana project. To put this into practice, let's look at the Asiana project in Da Nang, Vietnam. This high-rise project utilized a 850 concrete grade, 35 megapascal compressive strength with 150 millimeter slab thickness by utilizing soaring column intervals of 1.2 meter. The project successfully demonstrated that early removal is not just a theoretical concept, but a practical methodology that works in high-density urban construction. Key research findings. This research yielded several key findings. Most notably, we found that increasing concrete strength significantly improves punching shear resistance. Design strength safety. RC beam slab system remains safe when concrete reaches design strength with soaring spans up to 1.6 meter for punching shear, deflection, and crack width. If you look at this chart, it illustrates the relationship between soaring spans and slab thickness. We discovered that early removal is feasible even when concrete reaches a grade of only B12.5, provided that the soaring span is kept up to 1.6 meter and the slab thickness is at least 200 millimeter. This gives contractors a clear safety envelope to work within. And then the installation and removal procedures. For the first one, preparation phase, clean and roughen column or wall bases, install steel reinforcement, mark positions accurately, and assemble scaffolding for safe access. Then the next one is formwork installation, install column or wall formwork, followed by beam formwork with props. Then slab formwork with marked sequences for subsequent floors. Then the third one is concrete placement. Work the concrete and monitor strength development, ensuring proper curing conditions for optimal strength gain. And for the early removal, remove column or wall formwork at 5 megapascal, around 8 until 18 hours. Then beam slab formwork at required strength while retaining props for 2.5 floors. In conclusion, early aluminum formwork removal is highly achievable by carefully managing three factors: concrete strength at removal, then soaring span distance, and slab thickness. We can safely accelerate construction by up to 30%. For future research, investigating the effects of concrete admixtures to further optimize removal times is recommended. With over 100 reuse cycles possible and 20% value recovery in materials, this system is the future of sustainable, high-speed, high-rise construction. And I think that's all from me. Thank you, Lause, and all my friends for your attention. 谢谢大家。